Hello, my favorite algebra students. Hopefully you had a wonderful Thanksgiving break. I hope you ate a ton, slept a bunch, did a lot of fun things. I'm excited to hear about it tomorrow when I come back. But here we are, able to have a lesson when I'm not here. How cool is that, right? Excuse me. So today we're starting chapter 5, which is all about lines. And this first lesson here is on rate of change and slope. Rate of change, we've actually already talked about in class, we just haven't specifically called it rate of change. And slope, I'm sure you've heard of before in a previous math course you've taken in middle school. Okay, so let's just start from the top. Rate of change. Guys, all rate of changes is the relationship between two changing quantities. So an example you use all the time when you're driving would be miles per hour. That's a rate of change. A way you can think of this, guys, is the change in your dependent variable over the change in your independent variable. Since we're so smart, we know what these mean graphically. Typically, our dependent variable would be whatever our variable is on our y-axis over whatever the variable is on our x-axis. We'll do an example so this seems a little more concrete, but we've done this already. All last chapter when we were graphing, this is kind of what we were doing. So on problem 1, it says find the rate of change using a table, which is right there. So the table at right shows the distance a band marches over time. So we all know time goes on our x-axis, and our distance would be on our y. So our rate of change, guys, let me write this out. Rate of change, remember, is the change in our y-axis, which we just said was distance, over our x-axis, which is time. So that's our rate of change. Now, numerically, we got to figure out what that is. So what you do is, I look over here on this time column. So what am I increasing by each time? By 1 minute, right? I go from 1 minute to 2 minutes to 3 minutes to 4. And then I look over here at my distance. How am I getting from 260 to 520? I'm adding 260 feet. Same thing here, 260, and same thing there, 260. So if I want to find my rate of change, let's just take the easiest one and use number 1. I go 260 feet per minute, right? That's all we did, we just plugged in. I took my first column here. My distance was 260. My time was 1 minute. So after 1 minute, I walked 260 feet. Okay. So let's scroll down a little bit here. This question now is a little different. They say, is the rate of change in distance with respect to time constant? So they want to know if I'm increasing at the same amount. Well, we already showed that, didn't we, folks? Oops, I didn't need to do that. Here we go. Right, I know for every minute I go up, right here, I'm increasing 260 feet. So technically, we already know that this is, well, yes, duh. We are increasing at a constant rate, but let's show a different reason how, or a different way how. So let's say I pick this row and this row here. How can I show that I'm still increasing 260 feet per minute? Remember, rate of change is your change in your, well, let's say your y variable over the change in your x variable. So change, guys, just means kind of like the difference, so subtraction. So if I pick here, all right, so my y, I'm going from 1040 to 520. So I'm going to put 1040. How much am I changing? Well, we're going to figure out. So subtract by 520 over, now I look at my x variable, 4 to 2 minutes, so 4 minus 2, that's how far I'm changing. Now we just crunch some numbers here, okay? 1040 minus 520, 520. 4 minus 2, 2. Now I divide, I get 260 over what? Is that what we had up here? Bingo! Sure did, it all works out. So, yes, we mathematically just proved that it is constant over time. So this is kind of actually a pretty hard problem. The more of our focus on our lesson today will be finding the slope of a line using graphs, which is what we're going to go into right now. So in your own words, what is slope? Do you think slope and rate of change are related? Well, if you're an outdoorsy person, I'm sure you're thinking slope as in a mountain or how steep something is, but you can think of it the same way as a line. Slope is how steep a line is, right? So we have lines that go like this, we have really steep lines, we have really flat lines. That's all slope is. And how are they related? Slope and rate of change are actually the same thing. Typically, we refer to rate of change in real life examples, and slope would be just more kind of practice problems like on a graph. Okay, so if it says find the slope on problem 2 here, folks, of the following lines by using the graphs. So hopefully, if you've learned about slope before, your big thing you're thinking right now is rise over run, right? That's what slope is. Write this down and circle it a bunch. That is our ticket today. So you gotta think, how high am I rising over how far am I running? So if I look here, I have these 2 dots. How high do I have to go up? 1. So there's my rise. How far am I running over to my next spot? 1, 2, 3. So our slope we found is 1/3. Okay, so that's a positive line because it's increasing. Over here, on this next example, here are my 2 dots. Again, remember, you're rising, but actually here this time we're falling, but you still count up and down first. So I'm going down 1, 2. So since I'm going down, it's negative. How far am I running? 1. So I have a slope of -2. I hope this is clicking a little bit from previous classes. If not, all we're doing today is counting. Rise over run. Okay, so we're going to do the honor system here. Pause the video and try these 3 examples on your own. Okay, so all you're going to do is count the slope from the dots they give you. Okay, ready, set, go. Did you pause it? Or are you just waiting for me to do the problem? I hope you paused it. Okay, so let's do this first one here. We actually use the letter M to represent slope, so I'm going to start doing that now. So I'm starting at this point here, 1, 0, and I'm going to 5, -1. Again, remember it's rise over run. So how far am I going down? 1, so I'm going down 1. How far am I running? 1, 2, 3, 4. So I have a slope of -1/4. All right, moving on to the next one here. Starting at 1, 2, going to 6, 5. How many am I going up? 1, 2, 3. So there's my rise. My run is 1, 2, 3, 4, 5. 3 over 5. And number 3 here, starting at 1, 4 and going to 5, 4. So I'll start with your rise. Well, I'm not going up or down any, so my rise is 0. And how far am I running? 1, 2, 3, 4. So now I want you to take a calculator and take 0 divided by 4. What do you get? I hope you got a big old goose egg because this has a slope of 0. You guys see how this line isn't going up or down any, it's just staying a flat line? So horizontal lines like that one have a slope of 0. Okay? And then this last one here, let's just put 2 points since they don't give us any. Put one right there at 3, negative 2. How about 3, positive 2? So my slope, first you count your rise, so I'm increasing 1, 2, 3, 4, up 4. How many left or right am I going? 0, right? I'm not going left or right any. So now I want you to take your calculator and punch in 4 divided by 0. What do you get? I hope it's saying error or undefined or something along those lines because you cannot ever divide by 0. Can't do. Can never divide by 0. So a vertical line, so an up and down line, has a slope of undefined. And that's what you say. A vertical line doesn't have a slope. It's undefined because you can't divide by 0. So these are our 2 special cases for slope. A horizontal line, which is this example we just did, has a slope of 0. Maybe put a little trick. 0 divided by any number equals 0. A vertical line, which we just did here, has an undefined slope. You can abbreviate it UND because a number divided by 0 is undefined. It doesn't work. It's not possible. Okay? We will finish this lesson tomorrow when I'm back, but I just want to show you what your homework looks like for tonight. So let's look here on the internet. Let me grab it. So your first worksheet, oops, let me scroll you over. Here we are. So this one's just working with rate of change. There are just going to be a couple of graphs like they're given here, time versus height, and then you have to answer a few questions. It says determine the rate of change for the graph. So just see what's happening. For every minute, how much is your height increasing? Okay? That's kind of the gist of this worksheet. And then the other one says, let's erase this here. It says graph the points. Oops. There it is. Okay, it says graph the points and then find the slope. So they give you a couple coordinate planes here to graph these points. So on this first one it says plot the points 0, 2, and 4, 3. So over here I'm going to do 0 up 2, and then 4, 3, 1, 2, 3, 4, 1, 2, 3. So I have my 2 points, and now you just count your slope like we were just doing. So here's my rise, 1. How many am I running? 1, 2, 3, 4. There you go. First one's done. Okay? Try your very best. Help each other out. We'll figure out all the kinks tomorrow. Thank you guys for being so awesome. And I will see you tomorrow.